So let's test our new hash function, see if it does better than the bad string hash function we defined earlier. We're going to use the same test hash function we defined before that takes a function as input. So we can pass in either the original bad string hash function or the new hash string function that we hope will work better, a list of keys and the size, computing the hash value for each key, and records how many end up in each position. So let's try that again. We'll use the same example we had before using the words from Sherlock Holmes. And so we'll initialize words as all the words in the page that is the Adventures of Sherlock Holmes that we load from the web. So first we'll try this again with the old hash function, the bad string hash, and obtain the counts. And let's print those out. Remember what those look like. So it's a pretty bad distribution, as we saw before, ranging from 725 all the way up to over 2,000 in one bucket. Now let's try it with the new hash function. Instead of bad hash string, we'll pass in plain hash string. We're using the same words, the same number of buckets, and we'll see the distribution now. Looks a lot better, right? There's no values under 1,000 now. There's no values over, the highest one would be 1,363 in the first bucket. So let's look at that graphically. Here's what we had before. With the bad hash string function, we can see the size of the buckets varies a great deal, and we have the red and blue bars showing some that are too popular, some that are not popular enough. With the new hash function, we have much less variance. Still not perfect. We'd like to have all the bars really be as close to the same as possible, but it's really close. So this is working pretty well. The other thing we can try is having more buckets. So let's try this now. We're doing the same thing, but this time with 100 buckets instead of 12 buckets. And we can print that out. And so we see the results when we have 100 buckets are pretty good, but certainly not perfect. We have buckets as small as this one that has 104 and as large as this one that has 197. So almost twice the size of the smallest bucket. It's certainly a hard problem to build a better hash function. People put a lot of effort into building good hash functions. As your tables get larger, it's very important to both have the hash function be efficient. Our hash string function is not that great because it does take a long time to execute. If the string gets longer, we have to go through that loop once for each character. And so there are better hash functions available. We're not going to look at those in more detail now, but there'll be some links on the website to documents about more interesting hash functions. This is going to work well enough for us though. So before we go on to actually implementing it in the hash table, I'm going to have one quiz to make sure that you understand why this is so much better than the original index.